Hello everybody and welcome to this tutorial. Today I will show you how you can conduct today I will actually open up Wireshark and show you how you can conduct a live capture from a file. Thus far we have been using interfaces to perform live captures and to read from files afterwards. However, this time we will actually be performing a live capture from a file itself. This file is of type pipe, and we have previously created it in the previous tutorial. It is still here, it hasn't gone anywhere. So the first thing that we will need to do here is start up Wireshark. So just type in Wireshark as root. It's going to go ahead and start it. And go over to your virtual machine. Mine is Fedora 20. Yours can be pretty much anything you want. It doesn't really matter. And I have a prepared command here for you that I'm going to use. I have explained, if this command isn't too clear to you now, I have explained it in great detail in my previous tutorial, so you can just go back one video back and you will be able to see what each segment does here, what the TCP dump is, what SSH is, and what all of these arguments mean and do. Press enter here. You can see it says TCP dump listening on a specified interface, and it's prompting me for a password, so I'm just going to go ahead and type it in, press enter. And even though it seems like nothing is happening, believe me, it is. It's just that the output, the standard output, is being redirected to a pipe file elsewhere, namely to the destination machine. And in Wireshark, what you need to do is go ahead and click on Capture Interfaces. Here you have a list of those interfaces, but they are of no use to us at the time. You go ahead and click on Options, and you have in the right corner, it says Managed Interfaces. I have mentioned this briefly at the very beginning of this tutorial, but we really haven't had the chance to use this option. Now we do, so just go ahead and click on Manage Interfaces. You have two types of management. You have pipes and you have local interfaces. So just go ahead and click on Pipes, New, Browse, and find where go ahead and navigate to where you have created your pipe file. Mine is in TMP. I would advise you that yours be as well. Click on it, just double click on it. And there we go, TMP packet capture. Press save. You need to save it, otherwise this is not going to work. Close, and up here you see where I'm scrolling at the moment. Down at the bottom you will have it listed. It's going to be TMP packet capture, and it's going to be marked as well. So just go ahead and start the capture, and you can see that there's data streaming here. Pretty much this data, the one that you're looking at now, this is all our SSH encrypted traffic, and it is really not of that much use to us. We could decrypt it, of course, because we have the encryption keys. I have showed you how to do this with wireless encryption. Similar process with this as well, but for the sake of this tutorial, I'm going to go ahead and eliminate these SSH packets, as that is our own traffic and we do not want to be looking at that. Usually would apply a filter to TCP dump command. However, I did not, as I wanted the traffic to begin streaming in immediately so that you may see that it works, so that you would get a bit of a more verbose output, so to say. I'm just going to go ahead and I want the ping to be filtered out. ICMP, that's ping, that's a protocol for pings. All the packets are gone. There's a ton load of them down here. You can see at the bottom. However, none are displayed because I do not have any ICMP packets. But here I'm just going to go over to my Fedora machine and I'm going to generate a few of them. So just type in ping and you can ping whoever you want. I'm just going to go ahead and type yahoo.com, press enter, and I have pings going over. It's going to take a while for them to be received by Wireshark, as we are going through a pipe and there is always a delay. So you can see that the delay is quite significant. They're coming in one after another. My ping has stopped here, but here you can see that I have indeed pinged yahoo.com. You can see the destination IP address is here, and there you go, the second one is coming in, and it's going to take a while for all of them to pass through. We'll stop the ping here. It seems that Yahoo has stopped me before I managed to do that, but look at this. I have transmitted 36 packets and I have only received 10 of them back, which means I have a 72% packet loss. Don't know why. I wonder if I ping google.com, what will happen. Ping google.com. And these packets seem to be passing without any problems. Let's see if they will reach the same amount as the Yahoo ones. Yep, they're definitely going through. I don't know, maybe there's a connection problem there or something like that on the server side, or maybe it's not even a connection problem, maybe it's just a firewall rule blocking starts blocking after a certain amounts of pings have passed. I'm just going to go ahead and cancel this. It's going to take a while for all of them to be listed here, but that is not really important to us. I'm just going to go ahead and stop this capture process because the file size is becoming ridiculous. I have way too many packets here. And you can see that I have indeed captured traffic from a remote machine onto my own. Now I have done this between one virtual machine and one physical machine, however, which are in LAN. Basically one is within another, but it doesn't matter. The other one could have been, as I said in the beginning of the series, in Tokyo and the other one in Berlin, and you would have pretty much the same thing happening, although you would have a pretty big delay there. It would be pretty slow to, Wireshark would be pretty slow to receive those packets. It's not Wireshark's fault, it's basically bandwidth. If you had like fiber optics or something like that, that would go much faster. But you get the general idea of how you can do this. The process can be replicated to go over internet. There are no changes that you need to make of whatsoever, except if a computer is behind a router, then routers need to be configured to be able to pass through this traffic, to allow this traffic to pass through. Anyway, this concludes the series. I hope that you have enjoyed it, and this concludes the tutorial, the course as well. If you have any questions or something of a kind, I will be on Udemy, and there I will be answering them. In any case, I hope